Hello, Math 7 students. This is the percent and proportion review assignment. To get started today, students in class worked on this quick poll and students in class struggled. So we are going to go over it. Give it a try yourself first. It's okay if you make mistakes. We can learn from those mistakes, but see what you know first and then we'll do it together. Okay, class, are you ready? It's silent, so I'm going to assume that that means yes, I guess. What is the question asking? Well, let's read the problem first, I guess. The server at a restaurant brings you your bill. With tax, it comes to $20.49. But nobody pays just the $20.49, right? Good people, humans, will leave your server a tip. Yeah? Good answer. Everyone should always tip their servers. You're in a hurry though, and so instead of waiting for the bill to come back and then leaving the tip and everything else, you just leave $25 on the table knowing that the extra is going to be the tip, okay? So the question is saying, what percent was the tip that you left? This model helps it. And fun fact, on your test, you are going to be expected to draw some models. They don't have to be super detailed, but just something kind of like this, where we can see this is how much the meal cost, but this amount that we left is longer. Why? What is this extra amount? Why is it longer? What could this possibly mean here? Do you guys not ever go out and eat at restaurants? What would this possibly mean? I assumed you guys had been out to restaurants, but I mean, it is COVID time, so. Okay. Cambria, what is this amount? What does this even mean? Why is it longer? Yes, remember how we just talked about how we are going to tip our servers? This extra amount is longer because this is the tip that the server gets to keep for serving you all of your food. Bringing you your refills and taking your order. That extra amount is the tip. Read the question again now that we've made sense of the model. What percent was the tip that you left? I need to figure out what this amount is. I need to figure out what this extra amount is. How do I do that? Give me the calculation, Liv. Exactly. This is 25. This is 20.49. So we need to figure out how much longer it is. It's longer by doing 25 minus 20.49. And when I do that, what is the amount that I get? What is this tip? Dylan? 4.51? Great. So the tip is 4.51, right? Is that what we type into our calculator, is 4.51? Is that the percent of the tip? No, that's the actual dollar amount. So the actual dollar amount that we're going to leave the server gets to keep $4.51. But what is the percent? Remember, with percents, we always need to compare the percent or that amount to something. So when I'm asking what is the percent of the tip, we're going to take this tip and what are we going to compare it to? Please discuss with your groups so that I can have lots of people willing to share their answer with me. What am I going to compare this tip amount to? Okay, now come back and tell me, what are we going to compare this amount to? Luke. No, we do not compare it to the $25. That is one of the mistakes that I saw that was made, and here's why. When you leave a tip at a restaurant, you leave the tip based on what you already have consumed or whatever, what your bill is. You don't leave your tip based on how much you're leaving, because then that's kind of a vicious circle and you'll never be able to figure out what you're actually leaving it on. We need to compare the tip to the original amount. Haven't we said that lots of times before? We compare it to the original. What's the original in this problem? The original bill. And then later on, we increase the amount and then we have the total amount, or our new amount. This is the original. Does that make sense, Luke? So 451 compared to the original amount, which is 20.49. Lots of ways that we could do this. We could set up a proportion equality where I'm saying what percent was it? We can set that up. We could just do a simple calculation of 4.51 divided by 20.49, and we will get kind of a big, long, ugly decimal, 0.22010. But this is the decimal version, and since this is the decimal version, we would still need to convert that to a percent, and we would just keep it 22%. If we solve this equation, it's already moving that decimal place because we're multiplying by 100. And so when we solve this, we would get x equals 22.010, etc. And from there we interpret, oh, that 22 is the 22%. So the correct answer is 22%. Let's take a look at the review. All right, so students in class have already taken a look at the review, as I hope you will pause the video and look at the review as well to give some of these problems a try. Students have chosen the ones that they want me to go over, and I'll go over those first, and then if there's any time left, I'll go over ones that I think are the most important. So because it's a review, I will not be going over every single problem in the video, but the answer key is posted in Canvas, so you can always take a look and check your answers that way. One of the first ones that came up was they wanted to see problem number 14. Is that right? Okay, so a radar gun measured the speed of a baseball at 103 miles per hour. If the baseball was actually going 102.6 miles per hour, what was the percent error in this measurement? It's just like what we did in our last lesson. We have 100. Oh, that's not 14. Ha 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 ha. Just kidding. That's still a good one. Should we finish it since we already talked about it? Let's talk about it. Yeah, may as well. Okay. Here is what was measured. Is this the accurate amount? No, Mrs. Proctor. This is the accurate amount because it says it was actually going 102.6. So remember how we compare to the original? Or in this case, we're going to compare to the actual amount. The actual amount that we will be comparing to is 102.6. But remember, we need to figure out what the error is first. So how far off was that radar gun? It wasn't 100% perfect, right? How far off was it? Just like our warm-up, we have to find the change, or in this case, we're calling it the error. So that 103 minus 102.6 is equal to 0.4. That's our error. So it was off by 0.4 miles per hour. What was it actually? 102.6. So is this going to be a pretty big error, pretty small error? In the grand scheme of things, it's going to be pretty small, right? Type that into your calculator. What did you get? The error is compared to the actual or the accurate measurement. Anyone have that? I have it already. Luke, what did you get? Good. 0.00389. Now, this isn't the percent yet, right? This is just the decimal, but we need to convert that decimal to a percent. So as a percent, that is going to be 0. We'll call it 0.39%. You guys okay with that rounding? Okay. All right, now we'll go back to 14. So on this set of problems, it says find the percent of change, which means the first step, we need to figure out what the change is. Once I figure out what the change is, I'm comparing it to the original. And so in this situation, it's changing from 7,500 to 8,200. So what is that change? How is it changing? Maybe you're going to do that calculation. 8,200 minus 7,500 gives me 700. So it changed 700. What do I compare that change to? We compare that change to the original. Well, what is the original? What is it in the very beginning of this problem? 7,500. That's going to be just a simple calculation. We can set up a percent proportion if we wanted to. But with this simple calculation, I get 0.093 with the overbar over the 3. So convert that then to a percent, since this is a decimal, convert that to a percent, and we end up with 9.2 0.3% increase. Oh, it does say round to the nearest whole percent. So the nearest whole percent, that 0.3 is just going to make that 9 stay the same, so 9%. And is this going up or down? It's an increase, so 9% increase. Okay, what other ones do you want to go over? Any other questions on any of these? Okay, since no one's asking, I'm going to go over it anyway. Let's do 23 and 24. Ooh, maybe not. Let's do, what do I want to do? Maybe 23, 24, 26, I don't know. We'll see what we have time for. Look over those ones. You guys tell me which ones are the ones that you want to go over among 23, 24, 26. Which ones are the ones that you want to go over? Quick discussion at your tables. Okay, now let's just take a quick vote. Who likes 23 and wants to go over 23? 24. 26. That's the most of the hands, so we'll do that. Okay. What I want you to understand about 26 is it's the same steps as 23 with one extra step. Okay, so we have our original price of $18.99. We're getting a discount because of a store coupon, so it's going to decrease by 40%. So what I do with that information, I say, okay, that means we have 100% decreased by 40%, so 100% minus 40% is equal to 60%. So if I want to know what the price is right here at this point in time, what is that going to be? We take that $18.99, that's the original amount, and we're going to multiply it by the 60%. Calculatable is the decimal 0.6. 0.6, and that's going to give me some sort of an amount right here, right? Go ahead and calculate that if you would like to. We can do this in 2 steps. $18.99 times 0.6. I got 11.394. Now, here's some things to take into consideration. We're dealing with money, right? So how many decimal places do we need? 2. However, are we done with the problem? No. So should I round it right now, knowing I do only need 2 decimal places, but knowing I'm not done? Do you think it's a good idea to round right now? I'm going to say no. So keep all of those decimal places, even though we don't need them all right now, or in the end, we still need them now as we're still in the middle of the problem. Now I'm going to take that amount because that's how much I feel like I'm going to pay until I go up to the register and I'm like, oh yeah, taxes, right? And the taxes are going to increase the price by 6%. So that's going to be 100% plus 6% is equal to 106%, or calculatable, that's going to be 1.06. So I'm going to take that 1.06 and I'm going to multiply that by, I'm going to come down here because I'm a little bit out of space. I'm going to multiply that by this 11.394. And that is going to give me my new final price. Now, when we did this in class, we did it just a tiny bit different when we did this lesson, because I said, why take these 2 steps when you can do it in just one? Here's the only difference, is that 1.06 multiplied by, instead of calculating this, I'm just going to put that in parentheses and say, hey, this is still happening. That 0.6 times 18.99 is equal to the final price. Notice, these are the same thing, right? How did I get that 11.394? Because I did this calculation. So if you don't want to do multiple calculations in your calculator and take that little pause break, you can do it just like this. Okay? And what is that final price? What do you get? Anyone who has already done that calculation? Luke, go ahead. Tell me what you got when you typed in the calculation, and then we'll use that. 0.77. Okay. Now, good point. 0.7, we're like, oh, we only need those 2 decimal places, right? But what is happening with this? It's not being what? Yeah, it's not being rounded, and we need to round it. Because when it comes to the government, are they going to just say, okay, get rid of that 700ths or 7,000ths, get rid of that 7/10 of a cent? No, they're going to be like, nah, I want that. So we're going to round that up. They want that 1 extra cent. So 12.08. The final price would be $12.08. So it's just a matter of making sure that we're keeping all of those decimal places all the way till the end of the problem. And then when I get to the end of the problem, realize that the store, or whether it's the store or the taxes and the government, they're not going to give you that much of a deal, right? They're going to take that extra penny if they can get that extra penny from you. I would too. I would take that extra penny. Okay, with that in mind, let's go over, I want to go over 24 as well. Okay, so same type of process here, fewer steps, but same type of process. The original price is unknown. Whenever it's not known, that's when I'm going to use a variable. Just like I did here, I didn't know the final price, so I used a variable. I don't know the original price, so I'm going to use a variable. But I do see in this problem, it's an increase of 25%. So that means I have 100%, I'm increasing at 25%. That gives me 125% of the original, which calculatable is the decimal 1.25. What am I going to do with that? Well, just like I did here, I took that amount and I multiplied it by the original. So 1.25 multiplied by the original is equal to the final price. Well, what is that final price? It's $23.13, Mrs. Proctor. Yes, good job. $23.13. Now, in number 26, notice that the variable f for final price, it was already all by itself, right? Is the variable all by itself now? No. So we got to take that one extra step to solve. I can see that x is being multiplied by 1.25. I will undo that by dividing by 1.25. And that will give me x is equal to, I'll do this with you, 23.13 divided by 1.25. Ooh, another fun one. X is equal to 18.504. What are we going to do with that? In this case, is it going to be the 51 or is it going to be the 50? Quick check in with your groups. What do you think? Okay, and yeah, you all agreed it's going to be 50, right? As much as we would like to maybe bump that up to 51, this 4 isn't enough to make that round up to 51. So the original price turns out to be $18.50. We have time for maybe 1 or 2 more problems. Take a look at the review. What other ones do you want to talk about? What other ones do you want to see? All right, it was requested that we go over problem number 12 in class, so we're going to do that. Emilio and Regina each sell popcorn at the basketball games. The table shows how much they charge for popcorn, including markup for supplies and the number of bags of popcorn sold. So Emilio, all of his supplies, including the popcorn and the bags, cost $1.25. He marks it up 8%. Remember, a markup is like a profit, right? So he's charging more so that he can keep some money for himself. And Emilio sells 20 bags. Regina, her supplies are more expensive. Her cost is $1.40. She's only marking it up 5%. She sells 26 bags. So part A says, how much profit does each person make for each bag sold? Don't worry about how many bags they sold. Let's just focus on just one. So for Emilio, the cost of popcorn is $1.25, but Emilio marks it up 8%. It's asking how much profit. So do I want to go to the end final price? That would be a no. You guys are still sleepy today. The markup is the profit, so I only care about the 8%. I don't necessarily care about the 100% plus the 8%. That 100% plus 8% is going to give me the new total amount, or what they sell the popcorn for. This would be this, the retail price, what they're selling it for. This problem is not asking for the retail price. The problem is asking just for the profit. So that means I'm going to focus on this 8%. So what is 8% of 125? Sorry, $1.25. That's ultimately what this question is asking. How do I do this? 8% is 0.08. Of means to multiply. 1.25. What is 0.08 times 1.25? 0.1, or in other words, 10 cents. Emilio makes 10 cents per bag. Let's take a look at Regina. Regina's making 5% profit. So that's going to be 5% of her cost is $1.40. Or in other words, 0.05 times $1.40 is equal to, I got 7 cents. You guys get the same thing? 0.07, or in other words, that's going to be 7 cents per bag. So we now know that whenever Emilio sells a bag of popcorn, he's making 10 cents profit. We know when Regina sells popcorn, Regina is making 7 cents per bag. The question still remains, who made more total profit? So Emilio, 10 cents per bag, but how many bags did Emilio sell? 20. So that would be 20 bags times 10 cents per bag. Regina is making 7 cents per bag, but Regina sold 26 bags, so 26 times the 7 cents per bag. So Emilio made $2 profit total after selling all of his bags of popcorn, and Regina made $1.82 in profit after selling all of her bags. So who made more total profit? That would be Emilio with $2 profit. All right, now class is actually over. Students are already gone now, but they did not choose to go over any of these types of problems, and I think that it is important to go over these. So I am going to continue the recording without them and go over some of these problems. For each of these, you can solve them multiple ways. I will show you 2 different ways, and you can decide which one you like the best. The one that we're probably the most familiar with is actually these percent proportion equations. Remember, a percent proportion equation, like in 7 through 9, is a ratio equal to a ratio. And I think that those are really good ways to answer these questions as well. If I write a ratio equal to a ratio, we can find all the parts that we need and figure out what it is that we're missing. So 20% of 120 is what number? So 20%, this right here tells me 1/2 of that ratio is going to be 20 per 100. That's 20%. And it's going to be equal to, and it says 20% of 120 is what number? We don't know what that 20% is. We just know that it's 20% of 120. That means that we know that original amount, or that part that compares to the 100. And it's this mystery number that's the 20%. We don't know what that is. So we can set up this percent proportion. N is being divided by 120, so I can solve that by multiplying each side by 120. And when I do that, I get N is equal to 24. We can always go back and check our answer. 20% of 120 is, and then what I'm really doing when I'm typing in that in my calculator to check it is really I'm saying 20%. Let me rewrite this. Of 120 is what number? We can kind of just do like a direct translation, translate from math, or from English into math. 20% is 0.2. That's what we would calculate. Of means to multiply, and 120 is the number 120. Is means equals what number? That is the mystery number that we're trying to find. So this is another way that we can do this. 0.2 times 120 is equal to, again, N is already by itself. It's already solved, so we just have to do this calculation. When I type this into my calculator, I get 24 is equal to N. So that number is 24. Again, lots of ways that you can do this. Ultimately, I want you to see that this method here, which might seem easier, is exactly what we did here. This 20 over 100, or 20%, is exactly what this means. Ultimately, what did I do with that? I multiplied it by 120. I'll do that in red so you can see I multiplied that 20% by 120, and what am I doing here? taking that and multiplying it by 120. So it's the exact same steps. It just depends on how you want to interpret it and how you want to look at that. Let's look at 2. Again, I can set this up in multiple ways. We'll start with the percent proportion. I'm going to do it over here this time. And it says 15 is 15% of what number? So again, I see this 15%. So I know that that's going to be 15 per 100, or 15 out of 100. And I know that that is equal to, let's see, 15 is 15% of what number? I'm going to set that up as 15 over that. 15 is the 15% of what number? We don't really know. Now, again, lots of ways that we can solve this. If I were being super consistent with how we've solved these throughout this unit, I would say, look, the variable's on the bottom. So we need to flip that and then solve it that way. But we can also go with those old methods, like how does a 15 change to a 15? It's multiplying by 1. So what am I going to do with this 100? Multiply by 1, and it's going to give me x. This one's a nice easy one. X is equal to 100. Now, how can I do it this way with that direct interpretation? 15 is the number. Is, that would be an equal sign, just like it was up here. Is the equal sign. Is 15%, change that to the decimal. Of means to multiply. What number? That's what we're asking. So I've set up this equation just doing kind of a direct translation, and then I can see n is being multiplied by 0.15. So I would undo that by dividing each side by 0.15. And when I type that into my calculator, 15 divided by 0.15, I end up with 100 is equal to n. So again, 2 ways that we can do these types of problems. It just depends on which way you prefer and how you can interpret these problems. Let's see, let's just do one more. Let's do number 3, and that'll be the last one that I do from this section. 8 is what percent of 64? 8 is what percent of 64? So 8 out of 64 is equal to what percent? That's how I would set up that proportion equation. Or I can do that direct translation. 8 is what percent, I don't know, so I'll use a variable, of, that would be multiplication. 64 is just that number. And again, I have this equation to solve. N is multiplied by 64, so I will divide each side by 64. And when I do that, I have 8 divided by 64 is equal to n. 8 divided by 64 is 0.125. Now this is a decimal. I need to still change it to the percent. What is the percent? So I would say that is 12.5%. Solving it this way, one single solving step, x is being divided by 100, so I would multiply each side by 100. And I have 8 divided by 64, which is then multiplied by 100, and I end up with x is equal to 12.5. Again, that's already a percent, because see, it's the x per 100. So this, when we do this calculation, it gives me that percent already, 12.5%. 4 and 6 are similar, just not using as many words, but it's the same type of situation. And now let's just do one more from this section, and I think you can handle the rest. So 7 through 9, we're writing percent proportion equations, ratio equals ratio. We did a lot of that up here, so I'm only going to do one from this section. Macy has completed 78% of the 50 questions on the test. How many questions has Macy completed? So 78% tells me one side of that ratio is going to be, or one ratio, one side of that proportion equation is going to be 78 per 100. And she's completed 78%, but there are a total of 50 questions. So that 50 represents that 100%. The amount she's actually completed is the unknown. And now that we have set that proportion equation up, that's part of what you are expected to do, is setting up that equation. And then we finish that up by saying, oh, my title, there we go. How x is being divided by 50, I undo that by multiplying by 50. When I do that, I end up with x is equal to 39 questions. So there are 39 questions that Macy has completed. Okay, that's all that I'm going to do on this video. It's 30 minutes long, so that's plenty long enough. If you have any other questions on any of those, make sure you're checking the answer key that's in Canvas. That's it for today, and thanks for watching.